Hey guys, I'm back again. In this video, we're going to focus on some trigonometry. This question I took out of a matric paper. It reads as follows. If 13 sine b equals 5 and b is between 90 degrees and 270 degrees, determine the following with the help of a sketch and without a calculator. Leave your answer in root form if necessary. All right, so the first thing that we need to do is we kind of need to locate where this triangle is sitting. So we can see that it's not in the regular spot in the first quadrant where we're so used to drawing it. It is somewhere between 90 degrees and 270 degrees. So this is the first quadrant. This is our first quadrant. This is our second quadrant. This is our third quadrant. And this is our fourth quadrant. And how trigonometric ratios work is that all is positive here, sine is positive here, tan is negative, cos is negative. In this quadrant, tan is positive, sine is negative, cos is negative, and in this quadrant, cos is positive, tan is negative, and sine is negative. Okay, so now that we have that out of the way, we can see that our sine, or the ratio that is given to us, sine b, if we go and write it down, let's just check what it is. 13 sine b equals to 5. Sine b equals to 5 over 13. Okay, so we can see that this is positive. So we know two things. We know that the angle lies between 90 and 270, and we also know that the sine b is positive. So that is, or that tells us that this angle that they are referring to lies somewhere over here, and I want to use a different color to indicate it. This right here is the angle that we are interested in. So now that we know the angle, we can apply our trigonometric ratios to it. We know that sine is opposite over hypotenuse, so we can say that the side is 5 and the hypotenuse is 13. Okay, so we would like to know what this side is, because this just makes things so much simpler for going further. Okay, so we will use Pythagoras to solve this part, and we say that the hypotenuse squared equals to the adjacent side squared plus the opposite side squared. And in this case, we're actually looking for the adjacent side. We are referring to b when we are speaking about adjacent and opposite. So the adjacent side squared equals to the hypotenuse squared minus the opposite side squared, which equals to 13 squared minus 5 squared. And we don't want a squared, we want a, so we take the square root of 13 squared minus 5 squared, and we see that it's the square root of 169 minus 25, and that gives us the square root of 144, which makes or gives us a value of 12 for the length of a. But now, because we are dealing with our Cartesian coordinates, if we go, that is x and that one is y, we can see that this is on the negative side of x. So what we are going to do is we are going to say that this side is minus 12. Okay, so now that we have our triangle sorted and we made sense of our ratio, we can now answer the questions. Just take this away. Okay, so the first question says 5.1.1, determine 1 over cos b plus tan b. Okay, so we know that cos b equals to minus 12 over 13. So 1 over cos b will equal to 13 over minus 12. We also know that tan b is equal to the opposite, which is 5, over the adjacent, which is 12, so, or minus 12, sorry. So this gives us minus 5 over minus 12. Okay, so if we add this, we can see that 1 over cos b b plus tan b equals to 13 over minus 12 plus 5 over minus 12, which is equal to minus 18 over 12. And that, if we simplify it, we get minus 3 over 2. Okay, so that is 5.1.1 sorted. 5.1.2, let's just see if I copied it. Yes, I did. 5.1.2 reads as follows. They want to know what is cos 90 plus b. So I don't know if you've seen this before, but constantly it's just stated, and I'm not sure if you guys know where it comes from, so I will just briefly go over it. So when we have our co-angles, we know that this is equal to cos of A, cos of B, minus sine of A, sine of B. So in this case, we make A equal to 90 degrees, and then we have cos of 90 degrees plus B sorry, equals to cos of 90 times cos of B minus sine of 90 times sine of B. Okay, so we know that cos of 90 equals to 0 and sine of 90 equals to 1. So we can say that all of this is equal to, let's just write this down again, plus B, this is 0 times 90, oh, oopsie, sorry, 0 cos B minus 1 sine B, and therefore this is just equal to minus sine B, and this is simply equal to minus 5 over 13 as it's given over here in this ratio. Okay, so that is 5.1.2 handled. Okay, so I just want us to visit this here quickly. So the ratio, or the co-function that I used was this one right here. This is the one that I just used, but I want us to take note of these and how I usually remember them. Especially the sign, sine A plus B. I remember that S means that the sign stays the same. S means that the sign stays the same. And what I do is that I just know that cos is the opposite. Opposite. Cos is the opposite. Okay, so that's how I remember the sign, and then obviously the ratios exchanges. Cos sine A cos B, sine B cos A. I will do a video on the derivation of these. I think it's good to know, and I think it's good to understand where they come from, but that will come much later. Okay, so let's get back into this. Okay, so we would like to know what sine 45 minus B is. So again, we say sine A. Oh yeah, won't like it right. Sine A minus B equals to let's go back there if we can't remember them. Sine A cos B minus sine B cos A. That equals to sine A cos B minus sine B cos of A. Okay, and in this case our A is 45 degrees, so we have sine 45 degrees minus B equals to sine of 45 degrees cos of B minus sine of B cos of 45 degrees. And we know that sine of 45 degrees, if we look at our 45 degree triangle, let me just put it down here quickly. There's that one, there's that one. Oh, that's a let's just try and make the lines join at least. Okay, so if we look at our 45-degree triangle, we know that it is 1 square root 2, right? We know that in our 45-degree triangle, both angles are 45 degrees, and the sides opposite the angles are in relation. The 90-degree will always have the biggest side, followed by the other two angles. In this case, it's both 45, so it's 1 and 1. So it's 1 over root 2, and they are both the same. So sine 45 is 1 over square root of 2 times cos of b is minus 12 over 13, and then we say minus sine of b is 5 over 13, and this is also multiplied by 1 over root 2. So what we're going to do is we're going to take out the common factor of 1 over root 2, and we're going to say minus 12 over 13 minus 5 over 13, and that equals to 1 over square root of 2 times this is 17 minus 17 over 13. Okay, so we are not entirely done. Like I said in a previous video, we don't like, in maths, we generally don't like a complex denominator. So this needs to be normalized. So let us just do the normalization quickly. Let me just erase this part. I just want to copy this down. Sine 45 degrees minus b, that equals to 1 over square root of 2 minus 17 over 13. Okay, so like I said, we do normalization. I think what we can do is let's take away the brackets, and it's 17 over root 2 times 13. And what we do is we multiply top and bottom by root 2, and we get minus root 2 times 17 divided by root 2 times root 2 times 13. And this will equal to minus root 2 times 17. Let's erase this bottom part, it could become confusing. Okay, minus root 2 times 17, all of this over 2 times 13, which equals to minus root 2 multiplied by 17 over 26. And that right there is our final answer. So, take home messages, what was important to note and to do. Let's go back here to the first page. Okay, so the first thing that we needed to note was that the triangle was not in the first quadrant like we usually have it. It is somewhere between 90 and 270, and you need to know which quadrants that includes, and in this case it was between quadrants 2 and 3. The next piece of information that we should have focused on, or that we focused on, is that the ratio of sine b is positive in this quadrant, and the ratio of sine b is only positive in quadrant 3 between the angles of 90 degrees and 270. Should sine b have been negative, we would have known that it is in quadrant 3 and not in quadrant 2. So those are the two things that was going to assist us greatly in solving this problem. And then we used Pythagoras to solve the last side, and from there it's pretty much it's, for the most part, it's downhill. Then we used some of the co-functions where we had the cos and the sine, and we went into that. Like I said, I will still make a video on this, how to derive them, but for now, memorize and accept them. I very rarely say that, but with these I will. Anyway, thanks for watching. I hope you enjoyed it. If there's any comments, questions, suggestions, don't hesitate to drop a comment. Cheers.